We'll be talking about Logitech flight instruments and penguins. The name is Nikita Firsev. I work for Positive Labs, and we do all sorts of research there. Also, I love researching various stuff at home. So my presentation today will consist of three main parts, and it will start with a short introduction where I will explain how it all entered my life. After the end of the presentation, I will be happy to entertain your questions. So it somehow happens in my life that rather than me doing reversing, reverse engineering sort of looking for me, like I was not expecting to reverse engineer anything. I was going to have a good time, maybe play a game or something. And then I realized that I want to add extra functions or things simply stop working. So in my spare time, I love playing flight simulators. As any sim gamer, I realized that I need to build myself a proper cockpit at home. And once for my birthday party, I got Logitech Flight Instruments panel as a gift from my workmates. You can see it here on the screen, and it's also over there on the table live. It's actually a great device as it enables you to, push the buttons, turn the switches. You can actually feel like you've got almost a proper cockpit at home. But things are not that simple. I am a hardcore Linux fan. And obviously, manufacturers don't have a clue that, Linux players actually exist. They only have drivers for Windows. And selection of drivers is really limited to Microsoft. Obviously, they're not offering my favorite open source gear, which is actually great because it is designed for creating hardware cockpits. And in fact, there is so much you can do with it, except there are no drivers. Obviously, I started looking across the fora because obviously people like me do exist out there. And the only idea I found there was that you can have a virtual machine running a Windows and, then connect to Logitech. Then I told myself, come on, I'm a reverse engineer. I should be able to do more than that. And this is how I started looking for what have they got for Windows. And there are utilities for diverse simulators. I also found a small SDK which supports integrations with various applications. Now, the lib proved to be well documented. It did have a header file which described various control functions. And here in the main screen you can't see much, but just take my word for it, there were functions that would enable you to put any arbitrary picture on the screen and get button events, which effectively meant you could do pretty much anything. So I felt it would be pretty easy to reverse engineer the lib. Before reversing the lib, I decided it would be pretty useful to start by looking what it is there in the traffic to know what to go looking for. Pretty often we analyze traffic in different buses using logical analyzers, oscillographers that can cost you, half what an apartment would cost you. And here I decided that I don't really need an expensive device because Wireshark does a great job sniffing Linux packets. So I'm seeing here what's coming from a virtual machine running Windows apparently, so I see images being sent. I can actually start reverse engineering. Traffic sniffing proved to be pretty useful because Logitech proved to have two different instances of this library. So this one is called Direct Output, do not confuse it with DirectX, and has got two different versions for Logitech X52 and Logitech SciFib. FIP is actually Sci-Tech Flight Instruments Panel. There was a company back then that would produce devices for flight simulators. So the first thing I did was to open up the binary file that I had, and it proved to be for X52. So I spent some time looking at the functions, trying to find something that would make sense and would work. No luck. Then I found the right lib. I started reverse engineering it, and I found the command structure. And the command is pretty simple. It contains the server number, which is usually set to 0, the opcode, the size of data being transmitted, and data obviously sent in packets. Then I checked for the comments available, such as set LED, which lights up a LED on the panel. Another one, like an input from the panel. And I was thinking that would be enough. I have been able to sort of establish my own device for flight gear.
Yeah, this is the altimeter UVIT 15M. The image is right on the screen. It totally complies with what I see on my laptop screen. The right-hand handle can help you set zero pressure on the altimeter. And, I wrote a simple software piece on Python. And I received data from the UDP simulator, rendered it through the pill image, and then it would be displayed on the device. But it turned out that there is a small flaw. The USB 2.0 throughput was only enough for 15 to 16 FPS, and it might have been enough, but you always want more. And if you take a look at the list of functions in LEAP, you can preload the image and then generate it from the memory, and that gets you 60 FPS. But the memory of the panel itself is not that large to download all the errors and so on and so forth. The Start server was another interesting program, but I did not see a single app that would use it, and I didn't know how to use it. So, but I was a hardware reverse engineer, so I decided to dismantle the panel. So I dismantled the panel, got the microchip out, and I saw that it was quite simple. We have the AMX23, which is the main CPU processing unit, and the RAM access memory chip, and there's also a fine-tuning interface. You can see it on the X-ray. It's called. It's named UART. So X-ray is not required. You can use the logic analyzer and see what is happening on the pins. So if you don't have an X-ray, don't worry about it. You don't have to buy it.
Ну, естественно, самое интересное, наверное, лежит.
And I think this is the most important part, NAND dump. NAND is not an eMMC. You get raw data with various errors, and that means that you're going to have to understand how NAND stores data, how you can restore data. And AMX via VPN can be used to download the documentation. You have BCX on Python, so you identify the UBFS, unpack it, and what you see is the Linux. And by the way, you might have noticed that on the screenshot you can see that it's the MadCats Linux. If you Google MadCats, you'll find out that it's yet another company that manufactures devices for gamers. And actually, this panel was owned by three different companies. Sorry, Sci-Tech, Metcats, and then Logitech. Maybe this is the reason for it being so weird.
Внутри основным бинарем оказался FIP.exe.
The type exe is the main binary file, and that was the easiest reverse engineering task in my life. Oftentimes, when you reverse things in hardware, you might come across a terrible architecture with no disassembling guidelines, and then you have to make it on your own. Sometimes people use weird optimizations, and for instance, I reversed a disk, and people would use non-standard registers, and you see it in the functions, but you don't see the way the compilation file is returned. Its logic, it should work, but all of a sudden you get fooled, and which means that you have to double check every single line. But it turned out to be a fun reverse project. Every single function was identified but one, and the only thing I had to do in this particular reverse project is use the function that would print the opcode by a line. So this is the list of commands implemented by the control panel. It turns out to be quite different from the one in the lib. Some functions in the lib were only required by XP52 systems. And second of all, I received some of the undocumented commands, such as setting the brightness of the main screen, the main indicator, and it might look strange, but software engineers actually change the brightness of the image. They darken it. They did not change the brightness of the indicator. I also got info on reboot. I saw there was a service mode, and you can use it to create ITFX factory file. And unfortunately, I did not have the binary files, that's why I could not use this function. But my objective was to understand how the start server worked. That's exactly what I did. And it turned out, you might think that it's just an exec file, and for our ARM32, I just integrated, and this is the debugging log shown on the screen. Nothing actually works, as you can see. So I started looking into the problem. I made sure that the resolution was proper, everything was fine, and I found that the binary is in the /temp, and it is assembled with the non-exec flag. That's why I did not see any software for the start server. This command is documented, but it does not actually work.
Non-exec is ETC.
Non-exec can easily be removed from the etc start, and after that I could use my own binary files. Well, all I had to do was write my own server code. I decided to take a look at the way it can be displayed on a screen. It's just a frame buffer that uses FB-bled function to display the image. This is not the name I coined. That was done even before me.
The
input can be accessed through the flash event entry, and they just read the status of the system. So I programmed a small binary code, but when I executed it, the entire screen changed. So I started looking into the problem, and it turned out that there were 3 parameters in the binary file, 2 descriptors that go through the pipes for us to be able to talk to the host computer. The third one is the server number, and they want the message that everything is fine in a HID format, and actually the PC tracked that with the help of the Python code that I programmed. So I would just send the hello world line to the receiving PC. I was too lazy to assemble an OpenCV or do some cross-compilation, so I decided that I would program another awesome demo file. So actually I can show 2 demos to you. The first one is the snake that uses the very same indicator, and you can use encode to turn it around. The live game can be rendered, which actually means that you can render it with a good FPS, and it's faster than going through the frame buffer. So the first thing that we need to do is initialize it through the FIP init. Unfortunately, the screen is slightly different. If you're interested in learning more details, please get in touch with me after my speech. So I send the binary file. It generates a random image. The set image can be used to upload your own image. Then you start. This is the start button and the pause button that you can use. So basically, this is the way to run it. And there is an image with a penguin. As you might have noticed, I decided to patch the auto load so that you would see that it's Linux, and the default image changed from the black screen to the penguin image. And now I'll be happy to take questions, if any. If you want to play the game, you're more than welcome to do that. But please use the mic.
Исправлением команды с бинарями, короче, no exec flag.
Well, how did you patch the command flag with the binary files?
Функция обновления.
Well, the update function in the user firmware is non-existent, and they will never deploy it because I don't think they care. It's just $180 expensive. I don't think they care much about that. You're gonna have to make deal with what they provide you with. Thank you so much for your attention. Thank you for coming.